if we and the hard HDD, the one, then this is a file. So operating system consider even the device, any information as a file. So we are using the file. By the way, what is a file? How many files are you using on your laptop? Million? I don't think million. But almost a million nowadays. Several hundred. Several 100,000 files. So if you are running the antivirus program, you can check how many files are scanned. So it's easily the several hundred, the thousand, the files on your laptop. So how can you manage? What are they? It's a data structure to keep the information. Also, it is very simple data structure. It's a byte string. It's nothing but the byte string. Your notepad, your image, anything is the byte string. For example, the notepad. So I save the link and my first name here. But on your file, it will be the Lee and the new line character, then the JEONGKYU and until EOF or end of file. Okay? It's just a byte string. What about your image? Image is the same thing. Logically, image is n by n, the matrix. Each one is called a pixel. So if you are using color, so RGB, so there are 3 components. Each one is the 8 bit. So it's a 2 to the power of 8. So that will be 256 different color. The 256 different color. 50. So that is the reason it's total 2 to the power of 24 bit the color. Okay. So I think the 2 megabyte, 2 million different color you can represent. So 3 bytes for each the pixel that you can have. That are actually byte string. So first byte, the 3 bytes will be used for the first and first, 0,0, and next 0,1, and so on. And plus, each file has a different purpose. It has the header information, data structure. Notepad might be simple, but image may have something header information. This is the BMP file format. And it's compressed, and its dimension is 800 by the 600. Then starting the data, the pixel value, and so on. So file is the byte string to keep the information. Then how many files? It's too many files to manage. So we need something other data structure to manage such a huge number of files. Why? Because it takes a time to search the file from the millions of files. Okay. To speed up, we need to kind of directory structure or the Windows use the folder, and also sometimes we need to compress and sometimes index. So that software is the file system. So operating system also include a file system. How many file systems? Many different. So we will discuss more details about such a file system. Sometimes this is called the separate software. You need to purchase. You need to pay to use the file system. Also, it's a file system on top of the file system, or sometimes a universal file system, and then you don't have to worry about too much different file systems. Sometimes network file system, or the Unix file system, or the virtual file system. There are many different file systems. So file system is another important component of the data structure. Then, anything else? If you design, implement your operating system, what else do you need to consider? Resource. So that is the main thing. Okay. So resource allocator means there are many different types of resource, like the CPU. How we can use the CPU. So we need to schedule to support the multi-degree programming and also multitasking. Okay, so what about the memory? Memory is very limited. Professor Lee says it's the fast media, the 2x to be accessed by the CPU, but their size is limited, and also it's volatile. Then how we can synchronize? So that will be the resource allocator part and also main part of our operating system class. So throughout the semester, in the chapter 3, the CPU resource, CPU allocator, algorithm, we will discuss about the algorithm. And the synchronization, or the deadlock, and the memory management, the pacing in and out, and even the I/O management, we will talk about the such a resource allocator. Every time, each and every operating system use the different, the algorithm, different, the library. They add a new one every time. So even nowadays, many of the researchers try to develop the new algorithm for the resource allocator for better performance. And also, like nowadays, we need to consider virtual machine also. Virtual machine, how to share the virtual machine means that doesn't mean the hardware will be increased. We have the same specification of the hardware. On top of that, not only just one operating system, we can have another operating system, how we can allocate the resources for each the virtual machine. Okay? So this is the resource allocator we need to consider. This will be main part of the throughout the semester. Anything else for the operating system? I have a new idea for the CPU scheduling that we are going to learn in chapter 5. But how can you implement? Also, I'd like to develop the new file system. So the current NTFS or the FAT32 or the EXT2, EX3, they are not feasible to my application. So I have a new idea, so I'd like to develop. How can you develop? Do you need to investigate all the specification of hardware and starting from the corner and each hardware unit? So it will take a long time and it's tedious and painful. Instead, process management. That's another thing that we are going to first. We will talk about this one. We need to something. How can you store the character in Java program? You can use the string class. Did you create a new class for the string? Somebody already developed, right? So Java programming language, not only just the concept of the object-oriented programming to instantiate the object using class, but also Java already provides a lot of API. So they developed, the Java group already developed a lot of classes. There is a default. It looks like the existing, somebody already developed. Okay, so you can use the Java API for our application. Same thing. When we develop the new resource, the new algorithm or new library, we don't have to implement by ourselves the all A to Z. Instead, we can use the API. So operating system provide their own API, but system level API. Okay, that is called the system call. So sometimes it's called the API. It's the same purpose. So it's called the API, application program interface, but it's a system level API or system call, or sometimes it's called the system library. So when you develop the new operating system, you are going to provide such a set of number of system library for user convenience to develop the operating system, the library functionality. So how many? Usually, it's not the huge number of library. So it's around 150 to the 250, depending on the operating system. Yes?
What is API?
API is application program interface, like so if you are using the string is a class, right? Somebody developed the string class, okay? So this is the Java programming API. So you can just take a look at the documentation of this string. So you can just instantiate and use the string class. Okay? So you can simplify your program. Otherwise, you need to define the string like the class, and store the character, number of character as an array, and so on. So that's the similar approach. So operating system provides some of the function, okay, functionality that allow to access your hardware. Okay, how many? It's not that many. It's around 150 to the 250. Then it's a very nice, fancy. No, most of the such a system library is very simple, because the main purpose of the system library is performance, because it will be used a lot. Okay, it will be used a lot every time. For example, when you read the file, you open, and or some of the Java application, you can the file stream you can create. Eventually, file stream will use the fopen and read the data fread. Okay, this system library will be used a lot. So performance is the most important part. So they will not use a lot of the library, instead the most important. There are different types of the library. We will see the detail. So system level API or system call or system library is the another part of the operating system. Anything else? Very important part. She mentioned process. So everything is the process data structure. As I focus on the emphasize on the last week, the operating system starts with what? Creating the first process kernel. Especially kernel is the first process. So each operating system should have the how to start, how to define. In other words, the data structure of the kernel. So some of the nowadays, most of the operating system provide the kind of kernel virtual machine. So it provides the specific the compiler to compile the. So for example, I have the new library the H library. Okay. So whatever that is, I'd like to include this one into the kernel. Then the other application can access to use this library. Then how can the operating system provide the compiler to compile only the kernel, because that kernel is the first process to be. Nobody create, okay, the kernel process. Kernel itself should be reside on the memory. It should have the very details of the data structure specification. So that the kernel, the compiler will rebuild the kernel, then it will be loaded into the memory. Then after that, the most important thing another important thing of the operating system is creating the process. At that time, to create the process, we are going to use also system library. So in chapter 3, we will see how to create the process. Anything else? Just think about your operating system, what kind of the component or functionality you have in the operating system. Network. Nowadays, the operating system is not standalone. It will be connected. So network, the 6th is another important thing. And also, operating system, not only the network interface, but many devices. So it is not required for the operating system, but for example, when I purchased the new hard disk drive like 20 years ago, I need to install the device program provided by the vendor of the hard disk drive. Then sometimes it's a fail. I need to call the customer service. They will give the program. Then eventually, it will be recognized by the operating system. But nowadays, the operating system, even for example, the Windows, they automatically check or if that is genuine. Genuine means before operating system release, they actually open the specification of the new operating system. Then verified by this Microsoft for all the devices, if the vendor works. Then it will be the part of the operating system. So just like that, your operating system include such a the interface, the interface, the program, which specifically the network is the important part of the operating system. And plus, there are many other the functionality like the accounting or protection and privacy and so on. So these, by combining all of this, so this is the operating system, the component, which means when you design, when you start to develop the new operating system, you need to consider this kind of the operating system, the component. Then for each, you can develop you can design the more details. So operating system. So as we discussed, so operating system has the user interface, as we discussed just before. There are two main, the graphical user interface or the command line interface. Command line interface does not mean just cmd.exe, instead it's a shell programming and the terminal. And also the program execution, how to create the process. Because all the basic mechanism of the operating system is to create a new process to execute the program. And also I/O the operation, so manage all the device. Okay, that is another operation. And the file system manipulation, we discussed. Communication is a network, especially not only the external, the communication like the internet, but the internal. How many processes will be created? Many processes. Sometimes the several processes are working together, which means they need to communicate. So for that communication, the operating system provides a communication mechanism. This is the communication and the program execution are the main purpose of your first programming assignment. So you are able to create a number of processes, and also you are able to communicate. Nowadays, there are several methods to communicate the several process. The one is, this is called inter-process communication. In short, it's called IPC. For the IPC, there are several mechanisms, like you can use the shared memory for the communication, like the bulletin board. We have the bulletin board, and we have a number of processes, number of students. For the communication, you can post the message here, and the other student can watch. Or if you have any change, you can change the bulletin board. So it's a shared memory approach. Another one is using the semaphore, which will be discussed later. It's kind of send a signal. And nowadays, most popular approach is client and server. It's a socket program using the TCP/IP. So you can implement the TCP/IP communication for the process communication. So that should be provided by the operating system. Also, that's communication. Error detection. Operating system is in charge of to coordinate and allocate the resource. That doesn't mean it's perfect every time. So, for example, deadlock that we discussed briefly. So deadlock, as you understand, deadlock is stuck. So I need this one, but she hold, and she need mine, but I'm holding. So waiting each other. There is no progress, no proceed. The next step is called deadlock. Then operating system need to detect such an error and do something. So this is called error detection. There are a bunch of different types of errors. Okay, some of them can be detected by the threat, and the operating system should check. So the operating system should be in charge of such a things. Many of the time, OS actually ignore such an error. Why? For example, so I am in charge of this class, so I need to take care of the relationship between any or among any student. So whether you are friendly every time, so I keep watching. and I check whether you are paying attention to this class and everything, I cannot proceed my lecture because there are too many different cases of the relationship and happen. So mostly I ignore whether you are very friend or not. Okay, I am giving the responsibility to each the individual. Okay, instead in case something critical situation, I can involve. The OS is the same thing. The main purpose of the operating system is a performance. To better performance, instead of involving all the problem. So for example, to check the deadlock, it is really complicated. It takes a long time. So instead, actually the OS ignore the deadlock. What will be the solution? From time to time, you Control C. Send the interrupt signal. Control C means it's the interrupt. So you can stop the current like the infinity loop is running. Then that is kind of the error. Then OS cannot take care whether this is the infinite loop or not. Instead, the user, if you feel this is slow, Control C is a full sleep. You can force the interrupt signal and stop it. So that is the error detection. And as we discussed, the resource allocation. Nowadays, accounting is getting more important. For example, the virtual machine, the cloud computing. So we have the hardware, but it can be used by the several virtual machines. But we need to build. How to build? We need to use such accounting information or journaling information. And protection and security are the more important nowadays. So this diagram shows all the service that we have discussed. Between the hardware and the user, these are the operating system, or most of the part of that. Okay. We will discuss most of the part throughout the semester, including user interface and program execution in the process management and I/O file system communication resource. So resource allocation covers the most of the part, and not the protection and security. So that will be the advanced topic of the operating system. So we will quickly see the command line at each part. So first one is command line interface. So command line interface is kind of sometimes called interpreter. What is an interpreter? Interpreter. It's a compiler, okay? But it's the line-by-line compiler. Anyway, computer cannot understand directly the human natural language. We need to change, we need to translate, we need to compile. Then, the one way is we can provide the entire, the high-level programming code, source code, then compile at once. That is called the compile. Another approach is the command by command, okay? Submit it, then the computer can understand. One of the functionality of the command line interface is the compile, but line by line compile, that is called the interpreter. So that is called the shell programming. I guess the reason why it's called the shell is most outside of the terminal program. So because of that, it's called the shell. If you look up the textbook regarding to the shell, each shell textbook is this much. So which means 300 to the 500 pages. And also, this is a programming. You can do the shell programming. We will learn the very briefly shell programming. Shell programming is one of the important part of administrator. So if you are interested in the system administrator or network administrator or the Unix administrator, you should be familiar with such a shell program. It's not one of the example is the Perl or the PHP. It's a shell program language. Okay, similar you can do the same thing. You probably see the script that starts with the USR in Python. The first line is like this. What is this? It's called anyone? Shibang. It's called the Shibang code. Shibang. I'm not sure the bank. Shibang code. I guess because it's a hash from the hash. It's called the Shibang. Shibang means it's this line of code used is the shell program. So when you are using the Python with the command line interfaces such as the terminal or the Mac OS, you need to provide the Shibang. Windows not. Windows ignore this. Okay. So such the program is called the shell programming. Shell programming is very useful, especially the administrator job. So we will learn in the exercise lab such as shell programming using the Bash shell. Bash shell is most popular BASH used in the Linux. But there are many others, the K shell, C shell, Bourne shell, and just the shell. Okay. It's a terminal program. Don't be confused with the CMD. CMD is not the shell programming. It's just the interface only. Okay, this is the example of the Bash shell, the Bourne shell, used in the MacBook. Okay, it's exactly same as the other shell programming. Because of that, many of the old developer prefer to use the MacBook because of the terminal. Also, so this is the shell interface used in the. I think it's not default. If you want to use the shell on your Windows, you need to install some developer option. I think I already did, but I forgot how to install. So for example, when I type the ls means it creates a new process. Okay, for the ls from this terminal. So that is the shell. Also, if you are using another way to practice, you can use the GCP. I will introduce the next class. You can use the VMware with the virtual machine on your operating system. I think something wrong. So I showed the last time. Another way is the Cygwin. So it's very small, but the Cygwin is not really the Unix. The program is kind of pretending. Okay, it's just a wrapper for the Windows. Inside, it uses the Windows library, but the outside interface is like the shell, the interface, command line interface. It's different from the Bash shell, but if you want to practice the shell programming, you can use the Cygwin also. So this is a history of the interface. So starting from the long time ago. Oh, by the way, 1970 is one of the important year in the Unix system. So it's the first Unix system, commercialized Unix system, started from the 1970. So what about your laptop and the computer? What happened out of battery? Well, no power. Do you lose the date and time? No. Actually, inside your motherboard, there is a battery. So because of that battery, so you can still keep the time and the date is going on. What if you replace the battery? It will be reset to the January 1st, 1970. So 1970 is the first starting date of any operating system. So that is 1970. Then, so we have this is an early version of the graphical user interface. So you can see the mouse pointer is still used currently, which means I don't think, it's a personal opinion, such an interface is not very human friendly. So like using the mouse or even the swipe and the touch, I'm not sure whether that's really the human-friendly. Human-friendly, more like the think about the human history, the Homo sapiens, the maybe 5,000 or 10,000 years, we have used communication through the voice. Okay, sometimes the vision, eye contact, and so on. It's just the 30, 40 years to use the mouse using the fingering. So not sure. So sometimes we don't know whether this is really the changing the human DNA later. That's the feasible to the human life or not. So still, the human-computer interaction (HCI) is one of important the computer science area. What is the interface between the human and the computer system? Okay, user and the computer system. So this early version of the GUI is still used. You can see the same, exactly same thing, same interface. So think about that. This is also very important and interesting the computer science area to develop, to find the new. However, still the natural language processing is not perfect. So we cannot use the voice recognition. I purchased the Google earbud, but using my voice, so they said I can control the Google Assistant, but the success rate is just half. Probably because of my accent. That's not my problem. That's the system problem. They need to take care of even my accent. Well, sometimes it works, sometimes not. While I'm driving, so it may be different. So please think about if you are doing research nowadays. I know AI, especially the machine learning, can be a very important part of the human-computer interaction (HCI) part. So Xerox actually contribute a lot for the HCI, the human-computer interaction. I use the source and destination. It's very convenient. I have used this one a lot when I started my first job, like this. This is early version, the graphical user interface. Some of them still use, like the Windows version 1, 2. That's the Windows when Bill Gates start the operating system based on the DOS, MS-DOS. He used the Windows stack. It's still used. They try to change, but it's too much addictive for the user. They cannot change. There's such a Windows style, the interface. Actually, OS2 is from the IBM. They use the similar and actually much better in terms of architecture. But the IBM finally disconnect the service of the OS2, not because the OS2 is not better than Windows, but in terms of marketing, the Microsoft won the game against the IBM. So still some of the IBM product use the OS2 only for their internal use. But I have used a couple of times. It's much more convenient than the Windows. And the K-Desktop is from the Linux system. They need some graphical user interface. It's still developed, used in the Linux system. GNOME is the GNU version of such a graphical user interface. It's very similar as this. And I think that you are familiar with this.